Today's lesson is on drawing circuits with circuit symbols, and you know how to solve simple Ohm's law problems from the gizmo, but we'll also just do one of those. So on the screen, you can see on the left a picture of what a real circuit would look like if we could make one. This one has a car battery. That's pretty unusual. But then it's also got it hooked up to a light bulb. So we've got the symbol for a battery on the left here. And then a wire is just a straight line. And then a light bulb. We've got a voltmeter measuring voltage. And then how an ammeter is hooked up. And then another wire back to the battery. So just like in first semester, we don't like to draw pictures, so we drew free body diagrams with just like a dot and some arrows for forces. Again, we're trying to draw things simply so nobody has to be an artist. The next slide is just showing sorry, let me go to the next slide. Let's see if this works. All the symbols. We're not going to use all of these, but there were some missing from the last picture. Like we will sometimes use a switch. When they say conductor, this is just a straight line. They just mean a wire. Here you can see resistor. We're going to use that in the next slide. And later in the chapter, we're going to talk about a fuse that protects the circuit. So you can see some of the things that we'll need here. And I just wanted to clarify battery. So this one is technically two batteries hooked together. So each battery you have is a long line and a short line. So just to clarify that more, this would technically be two batteries hooked in series or like, next to each other. So that's what this means here. Okay, so let's practice drawing. And I'm using a new tool, so bear with me. My handwriting's not going to be that great on the screen. So we're going to draw, and it doesn't, in the main loop, it doesn't matter what order you connect things in. I don't know if you noticed that on the gizmo when you made it. So here I'm going to start with the battery, and I have a 9-volt battery. I mean, if you were doing that with AA's, you'd need 4 of them. So I guess I'll draw 1, 2, 3, 4 sets of lines here. Okay, and then I need a resistor. So I'm just gonna give myself space and draw the resistor over here. It's a squiggle, okay. I need to have an ammeter and a voltmeter. Now it says a voltmeter across it. A voltmeter is always hooked in a certain way. It must go in parallel, is how we call it. So it must go out here. That's what we mean by across it. Okay. And then the ammeter must be in series. So it must be either right before or right after. It really, in this circuit, it could be anywhere in the loop, because what we want to do is measure the current that's going through this resistor. So any electrons that go through the resistor will also have to go through our ammeter, so we can measure how many electrons per second are going through there. So I could put it here. I could also, let's try, like if I erase this part, I could put an ammeter right here. It would measure the same exact measurement whether I put it here or here. Okay, so it doesn't matter. And does it matter whether I put the battery on this side or the resistor on this side? Doesn't matter. Okay. Technically, the long line of the battery is the positive side, the short line is the negative side. So then if you ever get a question about which way is conventional current flowing, conventional current flows from positive to negative. So conventional current this is capital I, okay, would go this way around clockwise in this situation, the way I drew it. Now, if I'm grading your homework, if you connected the battery the exact opposite way, then you're going to have your conventional current going the other way around. I don't care, but you just have to label it so that I know, if the question asks for that, then label your drawing so that I can mark that correct, that you show conventional current flowing from the positive side of the battery to the negative side of the battery. Okay, and then the math of this is easy. You did that on the gizmo. So this is just a circuit with only one thing in it, one resistor and then the battery. So what the battery's job is to give potential energy to the electrons. It's boosting the potential energy by 9 joules per coulomb or 9 volts, okay? And then that potential energy is going to drop. We call this a voltage drop over the resistor. So really what's happening here is this is converting electrical energy into a little bit of heat inside the resistor, and then the potential energy is going to be back down to 0 right here. So in any case though, we're trying to find current is equal to voltage over resistance. So I know the voltage is 9 volts divided by the resistance is just 15 ohms here. So then when I get my current, then I really should do that in my head. Okay, but that's comes out to be 0.6. I've got 2 sig figs though, so this 0 doesn't count. And then my units for current are amps. Okay, so that's an example where we've drawn a circuit using the circuit symbols. Voltmeters always go, quote unquote, in parallel, meaning they branch out to the side of the voltage that they're trying to measure across. And then ammeters that measure current, or amps, they need to go right before or right after the component of the circuit that you're trying to measure current through. Like you're measuring current in a river, you could drop something into the river to see how fast it's flowing. We're trying to measure how fast the electrons are flowing through this resistor. So we're kind of trying to drop it in the same river that the resistor is in, kind of. Okay. All right. Thanks for listening.